Well, as I said, my name is George Dragowski, and I'm a professor of astronomy and data science at Caltech. So we live in a unique time in history. It is comparable in its impact to, say, Industrial Revolution plus the invention of the printing press combined, but squeezed in a space of a few decades. So let me recap what's going on. People, I think, over-focus on big data. The data are just incidental to our real business, which is discovery of knowledge. So how much data is there in the world? My estimate is that there is now approximately 300 zettabytes of data, proper data in the world, which is 300 billion terabytes or 300 million gigabytes. And that volume grows exponentially, doubling every year or two. Now, think what that means. It means that in the next year or two, we'll generate as much data as in all of the past history. And that is amazing. So that certainly opens many possibilities if we know how to extract knowledge from them. For the first time in history, we'll not be able to see all of our data. There's just too much of it. And so we need technologies that will take care of the data and organize them and store them and find them and so on and so forth. The next more interesting thing is the increase in the information content of the data. So that's why we talk about data-driven science as opposed to hypothesis. Or a simple way of saying this is let data tell you what's in the data, and then you design data mining experiments to actually find out. But at the same time, we have this increase in complexity. And there are probably patterns in the data we get today that simply cannot be comprehended by human mind unattended. And that's where we need help from a different kind of intelligence, the AI. We really are at the start of the AI era. And you can think of it as an alien intelligence that we created on planet Earth. It works in a completely different way from our own, a different substrate, different methods of analyzing things and so on. And sooner or later, and probably soon, it'll surpass our intelligence. Numbers I hear range from next year to 50 years from now. So this is how I see this. We have carbon-based brains, and we build these silicon-based brains. And it enhances our capabilities intellectually, but it also thinks differently from us. We don't want AI that's going to mimic humans. We want AI that thinks in a different way and finds solutions that humans didn't think of. This is my advice for you, which I already told you. You have to have these skills if you're going to do any science or technology research or just about anything really in 21st century. And so you have to learn that. But there is one thing to remember, which even university presidents don't understand, that computational science, which is what we've been talking about, is not computer science. We use things that computer science has produced. Just like mathematics is not equal to physics, just because physics uses mathematics for their research. So signing up for computer science classes may or may not help you. You should look for classes that actually applying these tools into something else. It doesn't matter what it is, but just learning how to use these tools for real life problems. And that's where they really become interesting.